3 algebra. We are trying this on the brand new toy that I have, the smartboard. So any glitches, we're going to blame on the board and not on me. But we left off PO8. We have done this already with integers and with decimals, and now we are looking at adding and subtracting fractions. And fractions deserve their own day, their own lesson, because they're just that special and sometimes can be just that confusing, right? What's that thing that you got to remember always when adding and subtracting fractions? What's the kicker? Liam?
Common denominators.
Common denominators. And the question is, why? Why do we need common denominators? That's just how math works, okay? You're going to find that multiplication and division, as you get higher in to the maths, is actually easier. I shouldn't say easier. There are less rules, fewer rules to multiply and divide something than add and subtract. Because when you add and subtract, you have to have what are called like terms. Have you heard that phrase before? Like terms, right? No? Let me explain. If you have 2 chairs and you add 2 tables to that, can you add chairs and tables together to get like chables or something like that? No, you're still going to have 2 chairs and 2 tables, right? They're not the same thing. Okay, you can add 2 chairs and 2 chairs to get 4 chairs. Okay, but when you add and subtract, you have to have like objects in order to add them. Denominators are the same thing. This is like having 2 twelfths and 5 sixths. Twelfths and sixths are different, right? This is like 12 chairs and 6 tables. You can't add those together. If you were a zookeeper and you had 2 lions and you got a shipment, like they ship animals, maybe they do, I don't know, 5 pandas, should you combine the lions with the pandas?
No.
No, what would you get?
Dead
Bloody pandas, right? You don't want that, okay? So you have to combine the like animals with the like animals, okay? Lions with lions, pandas with pandas, otherwise bad things happen. Denominators are the same way, okay? If they're not the same, we have to make them the same so that we don't mess everything up, right? So how do we work with this first example here? 2 twelfths and 5 sixths, yes?
Well, you could maybe do 6 times 2.
You could. Probably the most common way is to, look at that, is to multiply one fraction, the numerator and the denominator, by the same thing, so that now we get 2 twelfths plus 10 twelfths. Okay? Now you have 2 lions. You're getting 10 more lions. That's okay. That'll be fine. Right? And when you add 10 lions to 2 lions, how many lions do you have?
12.
12. 12 lions. Right? This would not be 12 24ths, because when you add lions to lions, you don't get like super mega lions. Nothing changes. You're just getting more of the same thing. If you have 2 of something and you add 10 of something, you now have 12 of that same something. So not only do denominators have to be the same, but they stay the same. You've heard this before, yes? Was that the best way you've ever heard it explained to you?
Yeah.
Yes.
Miss Davina did it a little better.
What did she say?
I don't even remember.
Oh, well then. Okay. So that's what the whole point of today is. Just reviewing that process of adding and subtracting fractions, getting those common denominators. Okay. And then of course we would simplify it here, right? 12 twelfths, what does that simplify to be? 1 whole. Okay? 12 twelfths equals 1 whole.
Yes, I was correct.
Yay. Okay? Good. No, that's we should celebrate all things. Okay. The next one, 1 3/4 minus 5/8. That mixed number causes a bit of an issue. Let's put it into an improper fraction. Who can remind me of that process? Yes.
Okay, so you add 1 plus 4, but you don't change anything, and then you do like 4 times 3.
So close. You have those operations backwards.
5 times 3.
You have those operations backwards. Okay? You would multiply between the 1 and the 4, and then add the 3. Okay? The reason why that the reason why that is how many fourths does one whole represent? How many fourths is one whole? 4, right? So if you, I can write in the margins, I kind of like, maybe I can. Oh yeah, I can. Nope, not gonna let me. Okay, how about over here? Nope, okay, very well. So if you have 1 and 3/4, that's like having 4/4 plus another 3/4, right? That one whole represents 4/4 plus another 3/4. That gives you 7/4, which is the same thing you get if you multiply the denominator by the whole and then add the numerator, okay? So multiplication, denominator times whole, and then plus the numerator. So now we have 7/4 minus 3/4, sorry, not 3/4, 7/4 minus 5/8, and hold on, that looks kind of like a 2. How do you suppose I erase on this thing?
There's an erase button. Wait, what?
Yes, where is it though? That's the question.
At the top? Is that at the top somewhere?
I press that, nope.
On the back.
Press like bottom left.
Bottom left, like over here.
No, like up a little bit. Like the,
What?
almost like
Oh, this thing?
Yeah.
Oh, which one's the erase? This one? This one.
That one.
Yes.
That one probably. Oh, no, that's.
Oh, okay. Woo, okay.
Is it clean?
Delete.
Try cleaning.
I don't want to delete everything.
No, try cleaning.
I want a more. Finder, okay, we'll clean.
Now try tapping on stuff. Oh. I don't like this new screen.
Blah.
That's.
Well, here, we'll just move this. Oh, nope.
Oh, boy.
Okay, we're gonna move you over here where you don't show up. Perfect. And this will move you.
Oh, there. You can delete it. If you tap. Wait, tap on it. Tap on it again. You tapped on it twice, and then see right there.
Oh, okay, all right. Getting it down. So anyway, so we have 7/4 plus 3/4. Why do we keep saying 3/4? Oh, because I have it up there. Oh wait, what do I do again now? Hold on, I gotta erase it again. So we gotta do this. Gotta tap on it twice, and then delete that. Okay, so we have, this is third time this time. We have 7/4 plus, no, it's minus.
What? I am so confused.
Me too. Hold on. This is why I don't have a smartphone.
How do you get from 7/4 to
Don't pay attention to anything like that. Okay.
What?
There. Okay. Here we go. So
Yeah.
1 3/4 becomes 7/4. We're subtracting 5/8 from that. We cannot. Why? Because that's what the original question said. Sorry, I went on a long tangent because I was trying to figure it out. But the 5/8 comes from what the original question said. So we can't subtract them as they're written because fourths and eighths are different, right? We can't take eighths away from fourths. They're not like terms. What do we do? What do we do? Common denominator. How do we get there? How do we get there? What is essentially, and this is why we had PO7, what is the least common multiple? That's kind of what we're looking for here. The least common multiple of 4 and 8. If we count by 4s, count by 8s, what's the first number that's going to pop up in both lists?
2.
2 is a factor.
8.
8. If we count by 8s or count by 4s, 8 will show up in each of them. 2 is a factor of 4 and 8. That's not what we're looking for here. We want the multiple, okay? So how do we turn that 4 into an 8? We're going to double the 7, double the 4, and that gives us 14/8 minus 5/8, which now we have the same thing. We have 14 of something. We're taking away 5 of that same something. And so 14 minus 5, 9. Our denominator doesn't change. It's not going to be 0. Otherwise, every single fraction expression that you subtract would always have a 0 in the denominator. Doesn't make any sense. Okay, we have 14 M&Ms. We eat 5 M&Ms. We have 9 M&Ms left. Right? Or in this case, 8s. You do not need to convert that back to a mixed number. Actually, once you hit pre-algebra, mixed numbers kind of go away. We don't use them anymore. We stick with improper fractions. So 9/8 would be a fine final answer. Next one, 11/20 plus 7/8. Again, we're looking for that common denominator. So if you start counting by 20s, you start counting by 8s, what's that first number that's going to come up in both lists?
Oh, 40.
40. Okay? How do we get there? We want a denominator of 40, and we want a denominator of 40. How do we make a 20 into a 40? Double it, right? And whatever we do to the denominator, we have to do the numerator also. So 20 times 2 is how we get the 40. 11 times 2 will become our numerator, 22. How do we make that 8 into a 40?
Oh, wait.
Times 5, okay? Times 5. So 8 times 5, 7 times 5. The 8 times 5 gets us the 40 that we want. And 7 times 5 is 35. And once we get that common denominator, we have 22 of something, 40ths. We get 35 more. 22 and 35, 57 40ths is our answer. Need not, if you could reduce it, then you would. We can't. Going back to a mixed number is not reducing, it's converting, so we don't need to do that. But there we have it. Okay? Questions on this? Is there another one you would like to do together?
All of them.
Well, not all of them. I want to save some of the fun for you.
All of them except all of them for.
If not, I'll let
except
you.
two,
I'll let you go. But I'm willing to do one or two that look particularly tricky.
Do the 2 and 2/5 minus 1.
2 and 2/5 minus 1. Okay. Now here's the next question for all you smart tech people. How do I erase everything? Or when I scroll up, does it stay? Let's check that. Game changer. Because with the other smart board, the ink moves with it, so it gets out of place. This one, it's like it stays on there. Love it. Okay. 2 and 2/5 minus 1 and 9/10. We've got some mixed numbers here. To convert to an improper fraction, the shortcut is to multiply 2 by 5 and add 2. The reason why we do that is because really each of these wholes represents 5/5. So it's like we have 5/5 plus another 5/5. There's our 2 wholes, plus the 2/5 extra. Total, that gives us 12/5. Right? Those 2 wholes, each of them are 5/5. We have 2 of them, plus the 2/5. That gives us 12/5 there. The shortcut is to multiply that 5 by 2 and then add the numerator. That also gives us 12. So 12/5 from the first one. What's our improper fraction for the second one? Negative 1 and 9/10.
Oh.
Or just 1 and 9/10. What's that going to be?
I got
19/10.
19/10. 10 times 1 plus 9. Okay? And we are subtracting those. So we got 12/5 minus 19/10. We cannot subtract them as they're written because we're not talking about the same thing. Fifths is not the same as tenths. So, what do you want to do? What do you want to do? What's the least common multiple of 5 and 10? You start counting by 5s, counting by 10s. What number pops up first? Ellie. 10! Ava, how do we get there?
You multiply 5 times 2.
Multiply by 2! Yeah! So this ends up being 24. Whoops. Oh, I get to practice erasing again. Double tap. Tap, tap. Double tap. Double tap. Double tap. Ooh. Oh.
Just move it to the side so you can't see it.
There.
Oh, yeah.
So we have 24 tenths minus 19 tenths. now that we're talking about the same thing, we're both talking about tenths. We have 24 of them, take away 19. How many tenths do we have left? Hmm? I thought you put your hand up. No? Yeah.
It's 1 or it's 15 over 10.
24 minus 19 is not 15?
What?
24 minus 19.
Oh, it's not, I'm sorry, I did 9 minus 4.
Right. So 24 minus 19 would be 5, okay? So if we have 24 tenths, we take away 19, we now have 5 tenths. That's not our final answer because what is 5 tenths reduced to be? 1/2. And so that is our final answer. Okay? 1/2. Yes?
Whenever you like do the 2 to 2/5 to get it to the other number, you do it kind of weird. Oh.
You mean like this right here?
Yeah. Why don't you do it like the normal way where you do 5 times 2, which equals 10, and then 10 plus 2 equals 12?
Which I did do, right? I wrote that in. I was showing you why that works. Because each of these 2 holes represents 5/5. So we have 2 5/5 plus the other 2/5. That gets us 12. You'll notice I didn't do that with the 19 tenths. I used the shortcut, right? But sometimes shortcuts are really only helpful if you understand why they work, right? Otherwise, sometimes you can not explain it to someone else very, very, very well. So I was showing you kind of the math behind the math. Ava, yeah. Okay, other questions, comments, concerns, complaints, compliments, congratulations, or criticisms? Yes? Okay. I'd like you to work on the rest of this for tomorrow. You've got 20 minutes to work on it now. If we don't play the number game tomorrow, it'd be the biggest travesty in history of travesties. Because you only have, about 10 to do, 11 or so. Less than that, and you have 20 minutes to do it. So, work must be shown. If I scroll down here, it says add or subtract. Write your answer in the simplest forms. You need to be reducing, and also you got to show me the work behind it. I did not give you this much space to write, just to use the calculator and then write your answer in. So make sure you are showing work, otherwise you'll not get credit for the assignment. Yeah. Yes. Now comes the fun part. If I close this, will it save the ink to the? Okay, I gotta make sure. Never let me click save. Because if I click save, it'll save all this ink on here, and I don't want that. So I'll have to remember that when I'm done here. But let's do the outro. That's how you math.